Okay.
Sir,
Yes.
sir, I had a question from a book.
Okay, go ahead.
Sir, how can we write a program to obtain prime factors of a number?
Okay, the trick is that basically মানে take any number মানে that I'll basically that we can work it out basically based on actually our functions. Okay, but still if you want to do it since there is no way of basically determining the prime number, so there is only some specific way. So the only thing is to way is that basically to take the number, check if it is a prime. So what are the conditions of to be number to be not a prime? Tell me.
To be not a prime,
Yeah.
So it
sir,
will either, so it will
divis-
not be one, and it
it
will
should be
have one factor
divisible
other
by
than.
a number other than one and itself.
Come again.
It should be divisible by any number other than one and itself.
Okay, so then how do I check whether a number is prime or not?
Yes, sir.
No. How do you check? How do you give
So
a
we
check?
can run a loop from 2 to the n minus 1, and if n mod I equal to 0, then it is not a prime.
Okay, good. That is one of the ways out. Can I short?
Sir, n by 2 till n by 2.
Yes, sir. N by 2 plus 1.
Do you require
Actually,
n by 2
only n
plus
by
1?
two will only n by two will be enough.
Okay.
Yes, if it is a int, then it's only n by 2.
Can you decrease it more?
Yes, sir. It can be n by three also if the number is not two.
কমাতে যা না n by 3, n by 4, n by 5 করতে থাক না। Say n by 2 basically. Okay, you want to check it basically n by divided by n by 2. Fine enough. Okay, then anything
Square
else?
root of n.
Yeah, right, exactly. So the square root of n basically actually gives you the total number of maximum it can be divisible up to. Okay, so you say that will be somebody said that from 2 to square root of n. So do I check for all the numbers from 2 to square root of n? Do I check for all between 2 to square root of n?
No, sir, if it's divisible by 2, then it will be divisible by all even numbers.
Right.
So we can make the even number 0.
Okay, good. So that means what will be a loop basically look like? Then what will be a logic like? So the logic will be basically given the number, you basically check whether it is basically divisible by 2. Okay, so divisible by 2 means basically you want to check whether the remainder is 0. So it will be a mod function, right? So if it is a mod divided by, if it's a mod 2, the number mod 2, if it is a 0, then obviously it is not a prime number. Then you do the check from what number to what number? 3 to square root of n, but numbers, right? So basically that will be 3 to square root of n, step 2. So it will give you 3, 5, 7 to square root of n. So if it is not divisible by any of these numbers, so you have got a prime number. Your game. But then you have to check each number individually. So even if I say to, even if I give you a problem something like print out, give me all the numbers between 1 to, from 1 to 100, all the prime numbers. So you have to take each number and you check whether the number is prime or not. Okay, so over there you can actually basically think of something like this. So since all or no even number is actually a prime number, so you can skip all the prime numbers. You have to do that checking, but then one thing is that what you can do is actually decrease the number of steps which you have to do. That is only the trick. Okay, anything else? Anything else? Okay, so we have done. Can you please excuse me, please? Okay. Hello, am I audible? So, what we have done till date is something like this. We have worked with basic data types, which are int, char, float, right? There are higher data types, other data, I won't say higher, other data types, other basic data types you can see. That is short int, then long, then long, that is a long int, and double. Okay. We have also so we have also worked with collection of same data types, that is the arrays. Okay, so I have given only a simple example of an array. We'll get into different sorts of arrays later on. Okay, today what we are actually going to do is something like what I actually say, these are derived data types. Derived data types. So this is basically what we say as struct or structures. Is the keyword is struct. Okay, so let's take an example. I want to find. I want to basically put an imaginary number. Okay, I want to basically have a data type by the name of imaginary number. Is it possible? How do I go about it? Now the imaginary number has got two parts. So imaginary, so z equals to x plus iy, right? Where I, or you can even say j. Okay, one can even say j. J equals to imaginary number. Again, one can also basically denote it by something like this. An imaginary number, one can denote it something like this also, x comma y. X comma y. Right. Now, if I say that my imagine my x, and if x and y both are integers, then how do I actually basically denote a certain imaginary number? So imaginary number also becomes a data type. So like an integer, which was a data type, a char, which was also a data type, a float, which was also data type, a shortened, which is also data type. Over here, I have to have another data type, which is a type of imaginary. The data type being an imaginary. Now, imaginary data type does not exist. So what I have to do, I have to actually combine all the basic data types to form a new data type. So one can actually imaginary int x, int y. So this becomes my data type. Okay. So when I say imaginary I1 and imaginary I2, then immediately one can actually basically say that imaginary is a data type. Imaginary is a data type which is data types, two other basic data types, which both of them being integers. And my imaginary data type, the data type is what we say to be as a derived data type. Okay. So today what we will do, we'll take up two topics parallelly. Number one, how to work with how to work with structures, and also how to work with functions. Okay. So one.c. So hash include okay, did I basically discuss about the scope of the variables anywhere? Scope of a variable.
No, sir.
Okay.
No, sir.
Okay. We'll talk about later on that part. I want to define a structure. struct. So structures, the structure is defined something like this. The structure, it's defined like structure name and my data types. Data type var1, var2, I go on. Okay, I can have as many of them. I can even have my data type, what we are talking of in between, that can also be a derived data types also. So those can also be structs. Right. By default, we'll start off with something where this imaginary number, the structure defined, the basic data type is defined in the before main. We'll start off with something like that. Okay. Now it's not necessary that your that depends on application to application, whether you want to basically keep your imaginary number, the structure defined inside any of the functions or inside the main also, that is also possible. But it is very much preferred that you define all the structures before the main. Okay, so it should be outside any of the functions. So what I can do is something like this. Okay, so imaginary I1, comma I2, I1, comma I2. So over here, what happens is that I1 is a variable of the data type imaginary, where imaginary is a derived data type having 2 integers between it, inside it. Okay, any question here? So let's give my enters. Printf. To access a part of a this thing of a structure, this I'm looking for. So I'm looking for the variable, the basic data type of the variable x of I1. So it will be I1 dot x. So since this is a scanf function, it will be an ampersand. Okay. One.
So this line 14 to 17, can you explain again?
Yeah, I'll come back. I'll just. 14 to 17. 14. The 14 is basically printf part. You're looking for this part, right? So to access
15 and 17. Yeah, those highlighted parts.
to access any variable, right? So what I'm going to have is something like to actually to define the variables. Define the variables of a structure is there is something over here. So it will be struct dot var1 and so on. Okay, so actually to define the variable of a structure is basically struct this one. Sorry, this one. Right. The structure variable is basically this one. To access any parts of the structure of the it will be this one. Okay, so that is how you actually basically access any part. So this is the structure which I've done. That is a structure with the structure name. Okay, structure. Let's take for example, structure name. Okay, structure name. Now, if I want to basically access any part of the variable, So over here, my structure name has got var1, var2, var3, varn, to varn. Okay. To access any part of that structure, I'll be working with a dot. So dot that variable name, dot variable name. So that is how I'm going to work with. So this is what I have done over here. This is what I have done over here. So this is the part which I'm accessing X of this thing. Now, since this is a scanf, so this becomes a variable. This part is a variable, and I'm going to access the ampersand of that variable part. Okay. Any question?
Sir, so what is that part of dot? Like dot x, we are calling from that structure from from that function struct.
No, I'm basically working. So imagine I1 is a variable name of the struct imaginary, right? This is a variable, something like int x. So if I say
Yes,
that
yes.
int loop, what it means? So loop is a variable name of the data type int, right? Similarly over here, I1 is a variable name of the struct imaginary, which is a structure. Struct imaginary I1 is a variable name. Now, what does each imaginary contain? It contains x and y, which are the basic data types. So I have to get into that part. So to access each and every variable or each and every variable of a structure, we actually access it by using a dot. We access it using a dot.
Okay, okay, got it.
Okay. So let's say, for example, I want to add. So I can have a something like this also. Result, right? So my result dot x will be I1 dot x plus I2 dot x. Similarly, result dot y equals to y. Any question here? So I'm accessing each part of the variable. My result. Okay. So let's see what happens over here. Let's see. Okay. So let's see what actually happens over here. So A dot out. So x of I1, so let's take for example 2, y of I1, say 3, second imaginary number. So this is the part which I'm coming to. This is basically 4, 5. Yeah. So I can have something like that. Your so 2, 4, 4, 5. Yeah. So any problem? Any question? Any question?
No, sir.
Okay. Now, so now my objective will be something different. Now what I'll try to do is basically I want to basically do all my stuff with these images. So basically try to find out the addition, I try to find out the multiplication, I try to find subtractions and blah 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 blah. Okay, so I'll start off with this this thing only. So I'll save as, for example, save as struct function. Okay, so what till presently what we were actually doing is basically you were actually working with some functions but which were predefined. So printf is actually a function, scanf also a function. So these are functions which are actually defined. So now today what we'll do is basically we actually define our own functions. Okay. As we had discussed in the previous classes, also as we had in the previous discussions, that which takes in some parameters and it returns some parameter. Now that returning of that parameter can be nothing also, which is actually a void. Okay, and it might not take even anything also. So that is also void, something like main. Okay, so today what I'll do is basically I will return something like this. So I'll work something like this. So I'll define 2 or 3 functions. So void add function, add imaginary, and it takes in struct okay. Before that also let's something like this. So let's have something like functions, simple functions. So we'll just work with simple functions. So let's say I have got number 1, I have got number 2. Okay, so rather if number, so if num is num, comma, result. Okay, and okay, done. So I'll so the objective of this program is something like this. Define, add, subtract, multiply. Then you can have SQRT square root of the sum of 2 numbers, of the sum of 2 square numbers. 2 square numbers. Okay. Okay, I believe so. This is enough. So let's take the add. So what I'm actually looking for, I'm going to basically, I have one function which takes into numbers, which takes into integers, and it returns a. So I can have something. So my function, I can name my function. I can have any names. As usual, the namings will be something like it does not start with the integer number. Okay, with any numbers or any special character, it does not start out with. So add fnc. So this is my function name. It takes in 2 variables which are integers. So integer num1, comma, right? This is 2 integers, and it takes another one num2, right? And it returns an integer. So this is the thing which I have got. Okay. So again, int, again, I have got, so let's say I don't work with the subtract, but that becomes a little bit, sorry. So the same thing. So I can work with multiply, int mul frequency. Again, it takes into numbers, int num1, int num2, and this returns a function. Okay. Then there will be a square root of the sum of the the sum of the 2 square numbers. Now, if I am going to find return of the square root, will never be basically an integer number, right? So it will be a float number. But then what will my 2 functions take? So square sqrt sum fnc. It takes in again two numbers, two integers, int num1 comma int num2. This returns a float. Okay, so these are what we say to be as definitions of some of the functions. These are the definitions of the functions. Okay, so I want to basically right now I want to define when I want to write the bodies of the function. So this one will be int fnc. It takes in again the two numbers, int num1 int num2, and I have something like this. So I just return this thing, int num1 plus num2. So it just adds it up and just returns that one. So I'm not going to use any other variables over here. Why use any other variables? It's just a simple addition, right? So just similarly over here, I have got malfunction return. This is it. Okay. Now this part, these are what we say to be as the of the functions. This is basically what we see to be as the signatures of the function, right? And these are my function bodies. Okay. Now, technically, if I wanted, I could have done something like this also. Okay, so you see that my add function does not have any signature, so it is defined before the main only. Now, why I'm actually all these signatures or all these bodies should be defined before the main? Because technically your main will be calling all these functions. So if you do not have the definitions, right? So signature, or you can see basically signatures or definitions of the function. Right. So if you do not have the definition of the signature of the functions in the beginning only, so the main function will not understand what is being called. So that is one of the reasons the function, either you give the function signatures in the beginning, or you can basically write the whole function in the function body and this function body before the main function. Okay. So the last one which I'll do is basically float. Sqrt sum fnc. So it takes in two numbers, int num1 int num2. Okay, now float. Now I'll be using this some certain function, something like this. This is the function which I'll be using. This is the function which I'll be using. Technically, that is a power function. Power is basically the power function. Okay, so there are three versions of this. This is defined in maths.h. So similarly, if I see this maths.h, so immediately I required my math.h over here also. I should include. So this is math.h. Now this function, you see there are three versions. One is basically the power function, which takes in a double, which is again a float number. It takes in two doubles, the x, so this will be working with basically x to the power of y, right? And it returns a double. So this is basically there is other one. This is basically there is another version that is a float, and there is another version which is basically long double. So it takes in two parameters, which is the x to the power of y, x and y. It does not take in integers. This has to be basically very. This has to be very much fixed. It does not take in integers, nor does it return a integer. Okay, so actually use this. I will be having I'll just say I'll actually use the first one. So this takes in a double and returns a double. Okay, it takes in two doubles and returns a doubles. Now my these are the two numbers which I'll be working with. So this is something like double power 1, right? This one will be power. Now I'm going to do it with a integer number, right? So but my number is basically an integer value. So what I can do is basically I can mask it num2, right, comma 2.0. So similarly I can have the same thing like you can have power 2. Sorry, this one will be num1, this will be num2. Then I'll be having I require the basically, so this will be basically square root I'm looking for.
Sir,
yes.
So of x comma y returns x to the power of y.
This one, sorry, no, what is this? Yeah, this returns x to the power of y.
Then shouldn't it be 0.5? Num1 comma 0.5.
No. I'm going to use this is the power function. Okay, so
okay.
I'm looking for x square plus y square. Square root of x square plus y square.
Okay.
Okay. So to find out the square root function, yeah.
So this function returns a float value, but this power will give a double value.
Okay, sorry. So we're looking for something like this.
Function.
Okay, well, sorry. So double. I'm using the other one. I'm using the first one.
Square root function.
Huh? I'm looking for the function of square root of x square plus y square. What I'm trying to do is square root of a sum, right? So it will be basically I'm looking for x square plus y square, square root of x square plus y square. So the first one is basically x to the power of 2, right? Sorry, num1 to the power of 2. So this tilde is basically, it actually denotes, in some languages, it denotes a power, right? So this is basically num2 to the power of 2. Okay. Now I'm going to do this. What I'm going to do, I'm going to work with the square root function, right? So there is actually a specific function by the name of square root only, that is sqrt. So this is a square root function. You see, it takes in basically a double. The first one, it takes in a double, returns a double. The other one, it takes in a float and returns a float. So I will do the first one because my data type is actually a double. So I'll use the first one only, right? So this one will be double result is equal to okay. This is something fun. Result, okay, equals to sqrt. It takes in two. It takes in a double. So my will be power 1 plus power 2, right? And then return result. Okay, so basically this is something like sqrt. I cannot give the square root symbol, so square root of So this one will be this. What I'm actually looking for is basically num1. So my function, I can actually define my function something like this. This function gives the result of square root of x to the power of 2 plus to the power of 2. Okay, so this is basically something like num1, num2. Okay, any problem with this function? So this is a self-defined function. This is a self-defined function which I've done. Okay, this can be equivalently written something like this also. This whole thing can be written in something in the same only model line as sqrt power double num1 comma 2.0 okay, this is another function plus so this is the same thing. This is the same thing. So I've done it in 3 lines. Okay. Any question here? Any question here?
Sir, result is of double type at the square root fun.
Okay, sorry.
function
And I have to change this part thing also, right? My signature I have to also change. So I was using this part. Double. Okay. Any other things?
Sir, the result variable in square root sum function and in the main function are 2 different variables.
Yeah, but I'll come to that later on. I'll come to this part later on.
Okay.
I'll come to this. So just forget this part right now. Forget this part. Forget this part. What about the main part right now? Just check this thing. Is it all right? This whole concept, is it all right? So
Yes, sir.
there are 2 signatures. The function bodies I have basically defined later on, or I have even basically added a function in the beginning also with the body itself. Okay. By the way, anybody was trying to enter. Okay. Okay. So now I'm going to basically call all these functions from the beginning, from the main. Okay. As somebody was suggesting, you can actually notice this result. There are variable, which is a variable in the main, which is actually has a basically a result also, and variable by the name of result over here also in my square root function. Okay, these 2 variables are actually basically totally different. Why? All variables have got something what we say as a scope of a variable. A scope of a variable, right? A scope of a variable means that how long that variable or in which part of the body of the function or of the program is your variable can be accessed. So this result, you can see, where since this is between the main body right? So this variable is a scope of the variable is only within this main. The scope of this result is only within the square root of the sum function. So this square root, this result and this result becomes totally different. This result is what we say to be as a local variable. This is what we say to be as a local variable. So there are this, if I'm looking for the scopes of variables, scopes of variables, I have got a global variable and I have got a local variable. This scope of the variable, the local variable scope of the local variable is within a function within braces, right, within loops also, right? So if I define any variable within a loop which is being allowed by a C++, C14 version, right? Since it is being allowed over there, so if you define a function, if you define a loop, just work within the loop, it can that scope of the variable that is only within the loop. So if you want to access that variable outside the loop, you will not be able to do it. A global variable is one which can be accessed throughout this whole function. A variable can, this, for example, this if you remember the structure, since it is not defined, so the global variable, to define a global variable, it has to be outside the main, outside all the functions. So I can have something like int so if I define, right, if I define any of the variables over here, this variable will be accessed by all my other functions. It can be accessed by all my other functions. So that so over there, that becomes basically a global variable. So the problem with the global variables is that since it is being accessed by, so let's take for example, you have got a project which requires something around 10 functions. Okay, now these 10 functions might not be practically in a 10 function. These 10 functions might not be basically written by only a single person. It can be written by about 5 persons also, right? Now, if I've got a global variable and if all those functions basically decide to access those global variable, what happens is that whenever a function is called, you do not know how the changes in the global variable will be done. So it is not very much advised that you should actually have a global variable. It is not very much advised to actually have a global variable. Sometimes it is all right, it is necessary, but then it is not actually basically, but if you can do without it, then so to come out of these global variables, what you can do is basically you can actually pass these variable signatures, variable values through the functions only. Okay. So this is basically the scope of the variable. This result being the local variable within this main, and this result is basically local variable between this function, that is a square sqr2 sum function. Okay. Okay. So let's say right now I want to basically take the.
Sir, can you please repeat the disadvantage of a global variable over a local variable?
Okay. What happens is that, let's say for example, you have got 10 functions, right? Your program can have 10 functions. Money is not necessary you have to have 10 functions. You can have more than 10 functions. Okay. Now, typically in the industry, those 10 functions will not be written by only one single person. Right? It can be written by about 10. It can be written by 4 to 5 functions also. 4 to 5 persons also. Now, if everybody has got the access to that global variable, right? If you have got an access, you have got the right to change the values of the global variables also, right? So whenever these functions will be changed, because at the end of the day, those 10 functions will be taken by the 11th person. Those 10 functions will be taken by the 11th function, and those 10 functions will be used in a program which you will actually basically will be the part of the main. right? Now the problem is that since that 11% does not know that how the global variable is actually being changed or be accessed by all the other 10 functions, so he will not be able to know what will be the effect of that of the changes of since of due to the effect of these changes of the global variable, what can happen due to the in the main program. It might seem confusing. I'll get back to this global variable part with a simple example. I'll get back to this very simple example. Okay.
Yes, sir.
Okay. So, but let's take for example. Okay. So printf. Enter first number. Scanf %d comma facing now. Okay. Now I'm going to basically call one of the functions up to the another. Printf to so addition will be a %d. Now since I know my function is basically taking two numbers and returns an integer, so I'll just basically make my life a little bit easier and just call my function over here. So it takes in the first parameter as an integer. Okay. Now whenever I'm doing it, I'm going to basically f num comma s num. Okay. So I'm calling my function. Then I'll be having my multiplication of the two numbers. So this one will be null function. And I'll be have now this one will be basically a double. So this one will be a what is how double is basically so double will be what should be what I am looking for double to print the double. Can you tell me? Percentage what? Percentage what? Percentage what? Okay, so let's take for example this thing. Okay, so let's see what it looks like.
So probably LF or
LF,
LF stand for
long.
long double.
so long double. Double is basically F only. Okay. Okay.
Okay, sir.
So, let's see what it looks like. Q. Okay, since there is something like I'm actually using a math lib, right? The math function, if I actually give a GCC, then my math function does not, what happens is that when I'm actually compiling, all these libraries are what we say to be is basically linked to my main function, to my main file. Okay. Now, unfortunately, when I'm working with a math function, this math.h, it does not get linked like as the stdr and stda library was actually being done directly, right? So I have to do something extra. So that is basically lm. So minus lm means that basically l is for the link, m means that basically the math library, right? So when I do, when I'm basically when I use the math library, so it should be always be gcc minus lm, and then okay. What is this? Why is this? Oh, undefined function. Okay. I should put this math.h. Yeah, that's right. Why is this so? Just hold a second, please. Undefined to square root. So there is a warning, okay? Pow, it takes a link with the minus lm. Yes, it is so. Okay, but just let's not waste time. Let's say we actually drop off this thing presently. We drop off this function presently. It's going to waste time. So I'll check it up less later on what's happening. I'll tell you then next year. You can see this nested is not allowed. Nested functions part, this is not allowed. And I have got so maths library, since is not working, this is all right. So my first number is 2 and my second number is 4. So I got something like this. I can give a slash n. I can give a slash n over here. Pound double number. Undefined reference to pound. Oh, yeah, sorry. No, mistake. My mistake. Dust. So this thing is n minus n. So there is a warning that is a percentage of requires a double, but argument here has integer types. That's all right. So it's actually basically a returning function which I'm taking. So let's see. Hit it out. So 2, 3. Where is this? So why is giving 0? 2 and 3. This is not supposed to be. This is percentage f, so there is no mistake over here. So this is basically returns a double, takes in 2 integers. Something like
Sir, sir, in line number 33, so the
Yeah.
function you have written
Line number 33. Yeah.
33, sir, why it is multiplication function?
No, my function is defined something. Okay. Oh, sorry. Extremely sorry. So this one be sqrt. Okay. Thank you. So these are the pitfalls of basically copy pasting. Please note that. So if you basically copy paste blindly, these are the pitfalls which you're going to have. So get that out. So 3, 4. Okay. So this is your output. This is the program. This is the output. So everybody understood the basically usage of a function.
Yes, sir.
Any questions? Any questions?
Sir, instead of float, why we are using a double?
Which one? This one?
Sir, in the square root of the sum.
Because the last function in my square root, I'm using basically the square root function. Okay, so if I actually see the man sqrt, you'll see that it actually takes in a double and it returns a double. Right, so that's why, and this is the value which I'm actually returning. So that is why it actually is a double. My result is actually, I'm returning a result. My square root is basically, I'm using the first function if you actually see. Right, so this takes in a double. If you see the line number 55, so I've defined a variable by the name of double result, and is basically a square root. Right, now I'm returning this result. Now this result is of the data type of a double, so that is why this double. Okay.
Okay, sir.
Look, but that is 31, 32, 33, I could have easily basically used another variable by the name of, I could have used this function of result. And then I could have actually done something like this. So result, I would have done something like this. Result equals to okay, this one I cannot actually use. The only reason is my result is actually integer data type, and this one is basically since it returns a float, so I'll be having some error. So I could have used my result in these ways. So what I did was basically I just had in one single line, I just used these two parts. Okay, so it remains the same stuff. It remains the same story then. Right, so 3 and it gives you something like 5.8. So I have given basically after decimal, I have given actually a 2. You can actually see it. So my after decimal is actually a 2. Right. Any question here? Any question? Because this thing I'm going to use in different versions. I'm going to do different stuffs like this after this thing. Okay. Okay. So let's take up that previous example where we had actually left off, which was what? Structural. Okay. Structural. So again, I'm going to do the same stuff. Okay. So I'm going to do the same again, basically define the functions. Now, let's define something that's void. So I am not going to return any stuff. So what I'm going to do, I'm going to do it all within the function only, right? So add func. So this one is basically struct imaginary comma im1 im2, right? So this is this thing. This is my addition part. Then I'll be having my distance functions. Let's say I've got a distance function, void distance function. So that technique against this. Right. And then I'm going to basically, so these are my function signatures. So these are my function definitions or signatures. Now comes my function bodies. So my function bodies goes like this. So add Control V. I can actually have I can have my struct. I can give a struct binary result. So result. I can have something like, let's say that if I copy this part, it will be easier. And then I'll let me have in this part. Right. So I call my two functions. Please note what I'm actually doing, my this variable, right, and my this variable. So what I'm going to pass right now is basically my add FNC. I'll come to it later on that why it just happens. I1, I2. Then I will be having my okay, now I'm looking for this part. My distance function. Okay, struct imaginary result. Right. So again, I'll be using that same thing. So my okay, this is a distance function, right? So I don't require a struct, sorry. So this will be a double distance, double serial. So you can see that this I have got three results. I have defined three results. One is in the my bean loop, which is a struct. I've got a line number 42. I have defined a result. I have defined a result in my line number 17, and I'm again defining a result in line number 15. Since the scope of the variable is actually within this function, so all these three results are actually different variables. They do not have got any. They do not have any relation to any of them, nor one can access the other part again. So my result will be result is equal to okay. Result will be basically SQR. Then power. It takes into variables plus power. It takes into variables. So this one will be সেটা হচ্ছে IM1 plus IM2 comma 2.0. Now since these are actually basically IM1 dot x actually, right? IM1 dot y. Now since these are two integers, I require to basically the double and the same thing will be actually happening over here. It's only that this one will be with a y. Okay, this mistake. Okay. Printf. The distance between the two numbers is percentage f rather say 6.2f, comma, result.
Sir,
Yes.
in line number 52,
Yeah.
sir, will it be sqrt power double of im1 dot x minus im2 dot x?
Okay. Sorry. Okay. And I'm going to pass my distance FNC with my I1, comma I2. Since I'm using my square root, so I require my hash include. Math.h. To actually see basically what are the functions which are actually available in maths.h, into math.h. You can see these are all the functions which are actually available. So these are the functions: cos, sine, tan, float absolute, float mod, mod function, square root f, hypotenuse, square, float, seal, sine, arctan. So these are all the functions which are available with your math.h. Okay. So
Sir, I am using Dev C++. How can I means find a list of those functions in Dev C++?
it remains the same. It remains the same. These remains the
Okay.
same. These are very standard. Okay. So first number is, excuse me, there is some mistake. What was happening? Okay, sorry, Control Z. This one will be struct one. Oops. Undeclared. There's a problem. Line number 45. 45. Oh, sorry. So this one will be IM. So these are again the pitfalls of copy pasting. Please note all the pitfalls of copy pasting. Yeah. So the first imaginary number, it will be basically, let's take for example 2, 3, 4, 5. Yeah. So the addition will be something like this, and this is something like this. See what we have actually done. Hello. Everybody can hear?
Yes, sir. Yes, sir.
Now you are audible.
Sorry, my it's just got a this something happened. So what is happening is that now you see, if you actually notice this function, I'm actually basically passing the variable of I1 to a definition function of IM2, IM1, right? What is happening is that the value of what is in IM1.
Sir, you are not presenting.
You are not presenting the screen, I guess.
Sorry.
Yes, sir.
No mistake. Okay, you can see everything? Hello?
Yes, sir.
Okay.
Yes,
So
sir.
what is happening is that
Yeah.
this, as I was saying, this is a function. If you see, this is my body of the function, right? So the add FNC, and this takes in two variables, IM1 and IM2, which is the structure, which is the data type, right? Now, what I'm actually doing is that when I'm calling this function, I'm calling this function with these two variables, so I1 and I2. Technically, what is actually happening is that the value of I1 is being copied into into this variable. So it's being copied. So it's being duplicated, you can say. So it's being duplicated, right, in IM1. And since it's being copied, so the whatever value is in I1 will also exist in IM1 also. So then this becomes very much easier. This is what we say to be as a call by value. Call by value. There is a call by name. So this is by basically a call by name. So there is something also what we say as a call by value also. So this is what we say as a call by name. These functions, whenever these sorts of variables which are being accessed to all these functions, only busy using the variable names, where the copy, where one of the values of which is the function which is when it's even called, the value of that parameter is being copied into another variable of the function, right? As something like this, where the value of I1 is being actually duplicated, is being copied into IM1, right? So this is what we see as by the call by name. So this is also again a call by name. Call by name, right? So there is something called a call by value. The call by value happens when I'm basically copying the value of it. Rather, is basically the copying the location of that variable. Hello. Copying the location of that variable into that function. Okay, we'll come to that later on. So presently, just note that this is basically what we say to be as a call by name. Okay. Any question till here? Any question till here? So now, thing is that you can see that basically every time basically what I'm doing is basically struct imaginary. So this becomes a little bit not only readabilities, it becomes a problem with. So to make it my readability of the program to be much more easier, so what I can do is something like this. So in this way, I can actually remove this. So what I'm doing, I'm actually type defing. So I'm saying this structure which I have actually defined, this structure which I have defined, struct imaginary small I, say basically imagine, say this one, imagine, right? So this structure imagine which I have defined, it can also be referred to as a variable name by the name of imaginary, right? So this will actually help me to just remove this part. This type defing actually just helps me to remove these word structs.
Sir, can you please repeat the reason behind this?
Okay, okay, let's take another problem. Save. Okay, so let's take a simple other problem. See, I have something like this. So let's take, for example, okay, say int kilometer, meter, centimeter. Say double float. Okay. Now I can have float. Float to be as kilogram, gram, and centigram. Right. Now this thing, float, kilometer, these are basically to be also, we can be referred to as distance, right? These are distance type, right? And this is basically a, what you can say, to be as a mass. So I can, what I, to make my life a little bit easier, so I can say type def in to be as a distance, sorry, float, sorry, and type def float as mass. Now if I just write this in distance, mass, so you can see what I've done is something like this. I have defined distance to be as a data type, okay, which is also which is a data type of float. So I can refer to my float to be as a distance also, to as a distance, and over here I'm referring to be as a float to be as a mass also. So what is actually happening is that whenever I'm saying, whenever actually basically I'm calling up, whenever I'm defining a variable km with a data type of distance, which is a data type of a distance, immediately this distance, what is going to happen, it will be understood that this distance, since I'm type defing my float to be as a distance, so my distance becomes actually a float. So this is actually mainly used readability concepts, for reading of making my reading concepts of understanding my program to be much more easier. So I can have something like this. Right now, if I say that printf, sorry, scanf, sorry, printf, enter the kilometer. So this one will be percentage f, comma, ampersand of kilometer, right? Printf conversion of kilometer to meter is percentage f. So this one will be basically km multiplied by 1000.0. Okay, so let's see what happens. So GCC type dev.c. Oh, sorry, my mistake. So this is basically 10.2. This happens. So you can see one thing, my kilometer, meter, centimeter, since I know these to be as a unitary part of a distance. So what I'm doing to make my life easier, so I'm just define distance or the float to be as a distance. So whenever I'm using this distance variable type, data type, right, immediately one can understand that this is basically a float type. So this becomes immediately a float. This is the same thing which I was actually doing over here also. This was the same thing which I was doing over here. So over here, my imagine was my struct imagine was my new data type. Struct imagine was my new data type, which I was defining to be as an imaginary. So if I actually call my imaginary to be a data type, right? So when I'm saying it's an imaginary, so immediately my system will understand this is of the data type struct. So in one way, I'm actually not writing my struct imagine, struct imagine, struct imagine. So technically, if I had not done something like that, I would have written something like this: struct imagine. So struct imagine and my imaginary is the same thing. The only reason because my imaginary right now has been defined to be as a struct data type. It's been renamed. You can say it's been renamed as a struct data type. So this thing will work. Okay. Hello.
Yes, sir.
But the thing is that there is only one yes sirs which I'm actually seeing. So if
Yes,
there are
sir,
no
yes, sir.
questions, then I'll understand that it's being basically going all right, right? So let's see what this is the same thing actually basically. Clear. So my function's name is basically GCC str struct type def -m. So this becomes basically 2, 3, 4, 5. So this becomes the same thing. So it's just basically renaming that variable with a easier variable name, which becomes more easier. So it just makes my life a little bit easier. Or just somebody writing something. Yeah, Kushal, I think I'll be leaving also. Enough. So any questions here till here? Mind it, these are again call by names. Okay, so these are all call by names. Just for your fun sake, I'll just show you. Since I was telling you basically printf actually returns something. What does a printf actually return? I'll just show you something like this. printf. Printf %d %d, which is actually again another call. Can anybody tell me what is going to happen over here? Okay, let's see what is actually happening. Much more easier to actually understand. So let's say, for example, say 5. Okay, see one thing /n. So just give I go 5. Excuse me. Oh, just hold on, please. Percentage. Sorry, /n. Now let's see what's going to happen. My mistake. So 5. See what is actually happening. If you actually notice this function, line number 12, this printf function is first basically working, right? This is being first basically accessed. Due to this accessing part, this line gets printed. Okay, now this 39 is actually a number which is basically, but that is what printf actually basically it's printed. If you actually see, so if I actually even remove this part, say %f, so one can easily see something like this, because much more easier. So 5, so 13. So see how many characters? 1 2 3 4 5 6 7 8 9 10 11 with a space 12, and this is the 13th character. So it actually printf actually prints the total number of characters which is being printed. That is as return value. Okay, so all functions have got return value over here. Okay, any questions here for this whole class? Any questions?
No, sir.
Okay, then we can basically stop now.